Hi guys, Buildzoid here, and today we're going to be taking a look at another reference GTX 980 Ti that I repaired. So I got this card on eBay for 15 quid. That's my main excuse for why I bought another dead 980 Ti, because I do have kind of... At this point, I actually have a lot of working 980 Ti's that were broken. I fixed them. But anyway, yeah, this was 15 quid, so I couldn't help myself. Probably one of the reasons why it went for such a low price is that the card came just as a bare PCB, which to me really isn't an issue. I have plenty of spare heatsinks from all the other dead 980 Ti's that, I've acquired over the years. Um, and also you can just like run a Morpheus or something, or, I don't actually care about the card being usable in a day-to-day environment. It's just like fun little project to mess with. So yeah, I got this thing for 15 quid on eBay. From the listing, it was very obvious to me that this almost certainly had a VCore VRM power stage failure, because the listing mentioned that like they couldn't get the card to start at all, because if they plugged it in, it would trip the short circuit protection on the power supply, which is not what the listing said, but it said like, oh, it makes the system unstartable. And the reason that is if you have a shorted power stage, then and your power supply doesn't suck, the power supply will basically see the short circuit and it'll immediately click off when you try to turn it on. So anyway, I thought this would be a really easy fix. As it turns out, this is probably the most involved repair I've done so far. Like, aside from like full-on VRM replacements, but I don't really consider that a repair, even though it kind of does achieve that. Like, if your VRM is complete, like, if there's like a burn through several layers and it's just like, yeah, then replacing the VRM is technically a kind of a repair. But I also consider that like a performance enhancing modification rather than just a repair. Whereas this, well, it got a bit out of hand. Anyway, so yeah, this ended up being really quite involved. Because this did have a dead power stage, which was this one. And I actually tried to record the power stage replacement process for this card, so like figuring out which power stage is dead and then removing it and replacing it, and that all went very well. And I got to the part where I replaced the power stage and I go to turn on the system, and the card takes like forever to post. So it got stuck on like the GPU initialization post codes for forever. So I think if you're on UEFI mode, I think it was sitting for like on 97 or 99 for a really long time, one of the like 90s. And in legacy mode, it would so in CSM, right? So compatibility support module, it would get stuck on the B2 code for forever, and B2 is like GPU initialization. So, but it did eventually get through the GPU initialization codes, and the screen would just be black. No splash screen, no nothing, just black. First time I think I've ever seen that before. Yeah, I don't think I've ever seen that before, so that was a first. I had no idea what to do about that, and I gave up on recording the actual repair process for this, because first time I've ever seen that, so, it's not going to make for a very entertaining video while I go search Google to try figure out what's wrong with the card. Because I've never seen a card just put out a black screen. At least I don't think I've ever seen that. Anyway, so my first thought was like, oh, maybe it has a memory issue, so I tried to run a memory test, which doesn't run because the card wasn't actually initializing. Like, it wasn't starting up properly. That's why it was spending so much time on the post code. That's why it would eventually just get to like black screen when it did finally start, because it didn't start. I don't know how it was outputting black, but it was like it did turn the monitor on, right? Because there's a difference between the monitor didn't turn on and the monitor did turn on and it's black. So that's what we were at. So yeah, tried to run a memory test, couldn't run a memory test because the card didn't initialize. I thought the memory test was like, I don't run that memory test often enough, so I wasn't 100% sure that my like memory test USB stick was working, so I had to check that with a different card. Anyway, eventually I just got the idea, like, either the core is like toast and that's why it doesn't initialize, or somebody tried to fix this before me, which, considering that this was listed as a bare PCB, chances are pretty high, and they maybe decided to just try flash the BIOS and they screwed it up. Or maybe the BIOS chip did actually go bad on its own, but I don't really believe that is a thing. Yeah. Like, VRM failures are common. memory chip failures are common. BIOS chips don't randomly go bad, in my experience. That's not a thing. I don't know why people think that you can fix broken GPUs by flashing the BIOS on them. If the GPU is broken, it's probably not the BIOS, unless you did something stupid to the BIOS. But anyway, so yeah, at that point I'm like, okay, maybe somebody tried messing with the BIOS chip, and that's why it's like not working at all. And I don't have a hardware BIOS flasher, and this card wasn't really cooperating with like anything. Um, so, instead of like flashing the BIOS chip, which is what I think most people would have attempted with like a hardware flasher, I went and dug through my big box of dead GPUs, because I have a big box of dead GPUs, and I found this thing. These are the remains of a MSI GTX 980 Ti Gaming X, I think. This thing had a power delivery failure that was so bad that the core actually shot solder out the side of it. So this thing was a totally dead. So it gets used for spare parts. And one of the parts that was still present on what's left of the PCB was the BIOS chip that lived over here. Well, now it lives over here. And yeah, that MSI BIOS was all that was necessary to get this card to start. Unfortunately, that wasn't everything necessary to get this card fully functional, because after the card started with this MSI BIOS, I was greeted with a splash screen and a whole lot of artifacting across the top edge of the screen, like just gibberish, as in like color gibberish, right? Because normally you have like your splash screen is black, and then there's like your motherboard BIOS logo. Yeah, this thing was like colorful gibberish on the top. There was some colorful gibberish also down towards the bottom of the screen. And by gibberish, I mean like just colorful pixels, not text or anything, right? I ran a memory test, and this time the memory test did run because we actually had a BIOS that was capable of initializing the GPU core, and the memory test looked like this. Yeah, so chip A01, A0, was completely impossible to write to. Every single bit on it was failing. Functionally, this is the kind of report that I would expect if the card if that memory chip was physically missing. So that was fun. Anyway, I do have a big box of dead GPUs, so I just went and dug through my... Also, I should point out, like, if this is the first time you've ever seen a MATS report, the way this works, like the chip labeling, is a bit weird, because you'll see that the report says that all of the errors are on FBIO A0. And the labeling for these chips on NVIDIA cards starts from... So actually, I'm going to put the MATS report away at this point. And so you have the indicator up here for the corner, and then you go to the opposite corner, and over here is your A set of memory, A set of memory channels. And the numbering is actually a bit whack because it's A1, A0, B1, B0, C1, C0, D1, D0, E1, E0, F1, F0. So anyway, Matt's report says that A0 is gone. Like, it's functionally not attached to the board. Probably some operation critical pin was just disconnected. I don't think the memory chip was actually completely toast. But I pulled the memory chip and it didn't, I didn't see any ripped pads on it, but I didn't really concern myself with that because, again, I have a box of dead GPUs. So that means I have a lot of spare memory chips. So I dug through my box of dead GPUs and I found this dead GTX 970. And I pulled 4 of the memory chips off of this thing, because I already had the PCB up to temperature to pull memory chips, so I may as well pull some extra ones, because, yeah, who knows, I'll probably have another card with, Samsung GDDR5 where one of the memory chips is dead, so I'll have those memory chips ready to go. I won't have to pull them again. So, yeah, pull a memory chip off of that GTX 970, reball it, put it over here. In the process, one thing that concerned me with replacing this memory chip is that we have the bulk capacitors for the memory power delivery filtering right over here, and these are tantalum polymers normally. I've replaced them, but normally these would be tantalum polymers. And yeah, I figured that I probably cooked them in the process of replacing this memory chip. Because after I replaced the memory chip, the artifacts went away, and I could run the memory test, and the memory test would fly with, pass with no errors. But then I take the card into Windows, I try to run 3D Mark Time Spy, and 3D Mark Time Spy has a whole bunch of artifacting all over it. And so I'm like, okay, maybe, like I didn't, you know, the BGA didn't, like, maybe I didn't solder this memory chip properly. Maybe these two memory chips got affected slightly by the, like, me soldering this one. These two might have, like, been affected by that. Maybe I cooked all of the tantalum polymer capacitors, right? Because you're putting, like, I'm putting on the memory chip with hot air, and that hot air is set to like 400 degrees Celsius. I don't know if that's best practice. I haven't broken a memory chip yet. Like, I've replaced a few memory chips at this point. I haven't cooked one to death yet. So I wouldn't necessarily, like, if you're trying to learn to replace memory chips, I'm not saying you should use 400 degrees Celsius hot air, but it works for me, and I haven't yet had a failure with that. But I figured the 400C, like, that could have easily cooked the tantalums. And the card did smell kind of funky when I was replacing that memory chip. So I was like, okay, we've got artifacting, so chances are, you know, maybe the soldering didn't go well, or the power filtering for the memory is just gone. Because I just blasted a bunch of tantalum polymers with 400 degree hot air in order to get a memory chip onto the PCB. So I replaced the capacitors. I also replaced the inductors in the memory VRM, because this is a relatively... It's not as common as the vCore VRM failures, but this is a thing that happens to some 980 Ti's, where the memory inductors will actually burn up, and then it kills the entire GPU. So, and I would like to actually, like, push the card in the future, and, like, pushing the memory voltage is one of the things that I'd like to do. So I figured, yeah, I'm going to upgrade the memory inductors before, you know, they blow up again. Or, well, they don't blow up before they burn up again. And so these inductors that I put on here, so normally the card comes with, like, inductors that are roughly this size. Actually, it comes with, yeah, it comes with literally these inductors. These ones right here that not, like, these aren't from this card. These are, like, the same inductors that you would find on a 980 Ti. EVGA also used them on the 970, and I'm guessing as well on the 980s. But anyway, so yeah, normally you'd have these, like, small 330 nanohenry inductors. And yeah, these just can't handle that much current because they're pretty small inductors. So I replaced them with these inductors, and these were originally in the vCore VRM of this dead GTX 970. These are 300 nanohenries, so slightly lower inductance, but not lower enough that it would be a concern. Like, I would have also been willing to put like 400 nanohenry inductors, but unfortunately, I thought I had a lot of spare 400 nanohenry inductors from like some dead Asus motherboards that I've taken apart for parts, but I couldn't find them. So I don't know where I put them, but I couldn't find them. So I went with these because I could find these. Now, one issue with these is these are through-hole inductors, so they don't really... I mean, you know, I could have just left them like standing straight up, and they'd be like... sticking way up off the board, and it would have made heatsink compatibility a pain, so I like bent the legs on them a bit so that I could fit them in this angle. Yeah, I think it looks kind of cool. It doesn't affect operation in any way, shape, or form. Yeah, and these will handle more current than the original ones did. But unfortunately, so yeah, so I replaced the inductors, replaced the tantalums that I thought I cooked to death. I replaced those with some aluminum polymers that I pulled off of this dead 290X. Wait, no, this is a 290 matrix. Yeah, so I pulled off the aluminum polymers off of the VDDCI VRM over here. Oh, also, when I finally, because I thought I had a lot more, like, spare aluminum, like, salvage aluminum polymers, because I'm not going to put, like, fresh, like, brand new aluminum polymers on a 980 Ti that I got for 15 quid. Okay, because, yeah, like, SMD aluminum polymers are, like, annoyingly expensive for capacitors. So, yeah, I'm not putting, you know, $4 worth of capacitors on $15 worth of GPU. I don't have, like, this just didn't make sense to me, especially when I have this perfectly good dead R9 290 with lots of spare parts. So yeah, pulled the polymers off of this. And at that point, I also discovered that these inductors are actually, these were 360 nanohenry, but I already had these on the 980 Ti, so... yeah, these are, like, if I have another 980 Ti, like, these will probably end up on some different 980 Ti, because I think I do still have one more reference 980 Ti that still has the stock inductors. So, and these are, like, actually, these might be a bit long for the stock pads. Um, so they might not. No, I think they might fit. That's like the main upside is that it'll fit like under a proper heatsink. Anyway, so yeah, replace the polymers. Also added this capacitor because more capacitance, more better. Since I already had the GPU up to this like really high, like had the board warm for all of this soldering, I figured I'd also just throw a bunch of extra multilayer ceramics all around the back of the board. Right, because at this point, I really thought like either it's like something like I didn't do a good job of soldering the new memory chip on, or the power delivery is like not doing so great because this 980 Ti had kind of a lot of issues. So I added a bunch of these multi-layer ceramics, and those came from this thing. It's all fluxy. Anyway, yeah, so you can see that I just like pulled those from all around the memory chips as well as from behind the core and just sort of scattered them around the memory power delivery. And after all of that work, upgrading the memory power delivery, also I did this right here. After all that work, I get the card into Windows, I try to run TimeSpy, it's still artifacting. So then I'm like, and at this point, I noticed that the card is actually reporting that the memory VRM is outputting like 100 watts of power, which is insane. Like, that's way too much power draw for the memory VRM on a 980 Ti. Like, these MOSFETs, they wouldn't handle 100 watts. So at that point, I'm like, okay, maybe this BIOS is causing the artifacting. So I try to go through a bunch of different BIOSes, but those just land me back into that situation where the screen is like the card just doesn't initialize, which is super weird because this is like some random MSI BIOS, and I was putting like EVGA BIOSes on this thing, right? And I was getting a lot of and it just wasn't working with the EVGA BIOSes, and I'm not entirely convinced that I was doing the NVIDIA BIOS flashes correctly. Because it doesn't make sense to me, but I don't do a lot of NVIDIA BIOS flashing because anything you can do with an NVIDIA BIOS, you can also just physically do with with a soldering iron, and I really do prefer like you can, as far as I know, for 900 series, you can mod the BIOS to have a power limit. You know what else you can do? You can just trick the power monitoring chip into measuring less power draw. So I don't really see the point in modding the BIOS on NVIDIA GPUs. So I don't really do a lot of NVIDIA BIOS flashing, and so I was very confused because, first NVIDIA NV Flash wouldn't let me flash the BIOS because it was like, hey, this is an MSI card and you're trying to put an EVGA BIOS on it, and I'm like, no, it's an EVGA card with an MSI BIOS chip. Now let me flash my damn BIOS. Got that sorted, and then I was left with like I flash an EVGA BIOS, boot, and the card just like it doesn't initialize again. So ultimately I ended up back on the MSI BIOS, and I'm kind of assuming that maybe NV Flash wasn't fully flashing the entire BIOS chip or something, because like this doesn't make any sense to me. But anyway, so yeah, the card's reporting that, hey, like, it's pulling way too much memory power, and so I was like, well, maybe it's, like, the driver's doing something weird because it's seeing too much memory power, and that's causing the artifacting. So I modded all of the shunts by stacking some 5 milliohm shunts from another dead NVIDIA GPU, but I don't know where these shunts came from. I just have a box of, like, salvage parts, and there was 5 milliohm shunts. They may very well be from another 980 Ti, so I popped those on there. And so now the card, other than the shunts, I also noticed that a bunch of, like, there was like 3 of these little multi-layer ceramic capacitors. Try zoom in on those, right? You have these tiny little multi-layer ceramic capacitors around the GPU core. Well, a couple of them were missing. You might even be able to tell which ones got replaced from my not so great soldering job. But like this one got replaced, like this one up here. Actually, you can tell, I think, from just how shiny the solder is. Wait, no, because it was 1, 2, 3, 4. Oh, right, yeah, this one got replaced, and then 1, 2, 3. This one got replaced. Anyway, so I replaced those. That was a horrible job. That is the one thing I regret doing to this card, because like the memory power delivery stuff that I did that didn't fix the artifacting, I would have done that anyway after I fixed the card, right? The multi-layer ceramics around the core, that, like, you have to hot air those on, or at least I have to hot air. I had to hot air those onto the card because I've not figured out any other way of like soldering these. And so that's a lot of heat that, I was like pumping into the like substrate and the core. That, yeah, I wish I hadn't really done that. That's the one thing I regret doing. Now the card still runs perfect. Like the card runs great now, but I don't like that is one thermal cycle that I really probably didn't have to subject the core to. So yeah. Anyway, so you know, I skew the power readings, I fix the little multi-layer ceramics around the core, and I'm like, okay, now it has to work. Still, I take it into Windows, and it's artifacting running TimeSpy. And the thing I forgot to mention with the artifacting is the artifacting would actually go away if I slightly underclocked the memory. That was the main reason I thought is like, oh, it's like a power delivery issue or something, because it's like it goes away if I do a slight underclock. So like if it was a major BGA problem, I wouldn't expect an underclock to really fix that, because like if there's a connection that's just missing, right? Underclocking the card isn't going to fix that. But that you would also not be able to pass the memory test if there was a like bad connection. At least as far as I know, you shouldn't be able to pass the memory test if there's like a memory connection that's really bad. So I was really confused, and at this point, I had done basically everything I could think of, except for the thing I should have done at the very beginning. I had, during this entire process of trying to figure out why the memory chips are artifacting, I never once tried to measure the memory voltage. Yeah, it just didn't occur to me that, hey, maybe I should check what the memory voltage is. And there's a thing you should know about a lot of NVIDIA cards, which is that NVIDIA cards, unlike AMD GPUs, very often have a memory voltage idle state. So, for example, a 980 Ti, when it's not doing anything, will have the memory running at 1.35 volts. And when it's running 3D games, or if you don't have the drivers installed, it runs at 1.55 volts, because that's the voltage that these memory chips need in order to run at their rated speeds. So after all this time struggling to figure out why the card was artifacting, I run the GPU Z render test, and I check the voltage by like I just have one of the multimeter probes on ground, and then I measure the voltage from one of these capacitors over here, because I have a heatsink on the card, so I can't get at the front of it. And also these capacitors, these are for core power delivery. These aren't for memory, these ones on the back. So yeah, I just measure off of one of the multi-layer ceramics back here. I actually stick the probe. This is one thing I really like about DVI ports. You can stick multimeter probes through them like that, and the probe will just like stay in there. I mean, these are tweezers, but you can stick probes through the DVI port holes. Can't do that with an HDMI, unfortunately, or a display port, but for DVI ports and VGA ports, you can also do that. So yeah, I measure the voltage while it's running GPU Z render test, because GPU Z render test like switches the memory to full speed. It switches the core to full speed. The voltage was at 1.35 volts the entire time. That's why the card was artifacting. Oh boy. This just never occurred to me that the card could like, be stuck at idle. That's just like on AMD GPUs, that's at least for memory voltage, that's not an issue. You'll have plenty of other like idle versus 3D load issues with AMD GPUs, but you won't have your memory getting stuck at idle voltage, because they don't like, especially AMD GPUs of the GDDR5 era, don't have idle for their memory power delivery. That's not a thing. So, it just didn't occur to me that I should check that. So as it turns out, yeah, the card was the card was just stuck at 1.35 volts on the memory. Probably related to the fact that I'm putting an MSI BIOS onto an EVGA PCB, but yeah, I decided I'm not going to look for a software solution to the problem, because like I mentioned earlier, there are hardware solutions to all software. Well, okay, that's not true, but like any kind of voltage related problems with NVIDIA cards can be solved with a soldering iron. So, yeah, instead of figuring out why the GPU driver wasn't letting the GPU hit 3D voltage for the memory, I decided to simply override it. And I should also explain how the actual idle power state works for 980 Ti's, since we're already on the topic. So the way this works is that this chip right over here, which is a RT, wait, not an RT, it's an NCP. Yeah, no, it's an on-semiconductor NCP 81172. Yeah, 81172. This is a two-phase VRM controller, right? So, like, it could be used for other things. NVIDIA typically uses it for memory power. Anyway, this has two pins on it. One labeled, I think, VID, and the other one labeled PSI. And PSI is like power state something, and VID is VID, like voltage ID. Yeah, it's PSI and VID. And so basically, these two pins, when the card, if the GPU driver isn't running, those two pins are permanent, like those are connected to 3.3 volts through some 2 kilo ohm-ish resistors. I think they're supposed to be 2.2 kilo ohm, but I measured it on this card and it was like 2.1 or something. Doesn't really matter. Both of those pins basically get connected, like get pulled up to 3.3 volts. And as long as those two pins have 3.3 volts on them, the memory VRM runs as a two-phase, and it runs at 1.55 volts. And if those two pins get pulled to 0 volts, then the memory voltage drops to 1.35 volts, and one of the phases gets turned off. This is a power-saving method. And the way this is handled is that this chip is, so those two pins are connected to the 3.3 volts. I think on this card it's actually a straight 3.3 volts from the PCIe slot. So through some resistors to the 3.3 volts over here, and then there's some 0 ohm resistors, so basically jumpers, that connect those pins to the core. So when the card starts, you know, this has 3.3 volts applied to the pins. You get your 1.55 volts when the card first starts up, and both phases are active. And then once you get into Windows and the GPU driver initializes, the GPU driver tells the core to pull the voltage on those two pins over here low. So yeah, so if I actually measured the voltage before the driver loads, the voltage was actually correct, which I didn't do anyway. Like, I never bothered to check the memory voltage on this card because it just didn't occur to me that it would be wrong. But yeah, so the way I fixed the driver, so the driver, for whatever reason, I don't know why the driver decided to like permanently get the memory voltage stuck at 1.35 volts. I kind of suspect maybe it's like a difference in how maybe there's a difference in how this MSI card handled its memory idle state versus how this one, like it might be different wiring or something, so it's like different pins being used for it. But either way, the driver was not letting this chip go up to 3D volts, so it was just pulling those two pins low. So the way I decided to fix that is if we look at the back of the card here, gonna zoom in. So yeah, if we look at this area right here, now these two resistors, right? So you have this resistor and this resistor. And I've actually moved them, because normally this resistor connects from here to here. And this one connects from here to here. And these are the two resistors for the that connect the PSI and the VID pins of the voltage controller over to the core. So, and I moved them because I don't want to, like, lose them. Like, if ever I want to restore this card to, like, stock-ish condition, right, I want those resistors to just be there. I mean, technically, like, these are 0 ohm resistors, so even, like, a piece of, like, a jumper wire would work just as well. But, yeah, I decided to just kind of move them out of the way instead of, like, completely getting rid of them. I might actually completely get rid of them at some point. But anyway, for now, they're there. Yeah, I moved them. So now the GPU core no longer has a connection to the memory VRM controller, and the GPU driver can't tell the memory to run at 1.35 volts. So it's permanently stuck at 1.55 with both phases active, and that's exactly what I want, because this card is only ever going to get used for benching. So yeah, what an adventure. Mostly because I was just like I don't even know what the logic behind not measuring the memory voltage is. Right? It seems pretty, like, simple. It's like, yeah, you should always, like, the first thing you do if you have a GPU that doesn't work, the first thing you do is you check your resistances, and then once the GPU does run, you check your voltages. I never got around to the second part. Right? And the reason you check resistances first is you check for resistances so that you know that there aren't any short circuits. But anyway, in the end, I got the card functional. I wouldn't say really fixed, because the memory VRM is now permanently stuck at 3D, like 3D state, right? So it's permanently at 1.55 volts with both of the phases running. I don't really see any downsides to this. Like, sure, the idle power consumption is higher, but this card isn't going to spend a lot of time idling. Or at least it's not going to spend enough time idling that I care about some couple watts of memory power draw. Like, I really don't get why NVIDIA has such like elaborate power management, especially for the memory. Like, I can kind of understand why their V-core power delivery is so wacky when you have like, 8 power stages with 6 inductors, because they're really like desperately trying to keep the 6-pin, 8-pin, and the PCIe slot perfectly balanced in terms of how much power is coming from where. I can kind of get that. I actually don't. But like, why does the memory VRM need to be able to switch between single phase and two phase operation and 1.35 volts and 1.55 volts when, a card like the 290X, this memory VRM is permanently at 1.55 volts, permanently running both phases, no power saving in sight, works great, doesn't cause issues, much better, right? So then there's NVIDIA cards where it's like, oh, the funny thing is, this isn't even the first card I've had get stuck at idle memory voltage. I don't know how it happens. And the other card was like not, like, didn't even have anywhere as many issues as this thing did. So yeah, I'm not a big fan of this whole having an idle state for the memory thing that NVIDIA has on their cards, because this is the second time I've run into a card where it's stuck at idle for some reason, and it's like, I don't know. Like, well, why? Anyway, so yeah, I got the card fixed, and now that the card is fixed, I did find out something that, well, like, I'm happy about, kind of annoyed about. This thing has an ASIC quality rating of 81.4%, which is really, really high for a 980 Ti. So yeah, I'm actually really excited to see how this overclocks. And I am also kind of annoyed that such a good core is attached to such a garbage VRM, because it already exploded once. Oh, I guess one thing I forgot to mention is this card, the power stages that it has are FDMF 6823s. The replacement power stage that I put on there is a 6820. This doesn't cause any issues because these are all 60 amp power stages, and it actually, like, if you... Like, actually, I wonder if we have a production date on this thing, because I'm kind of guessing that this might be like a later production. Oh, I don't know how to read these numbers for EVGA cards. Oh, I also forgot there was a transistor that was like missing over here. I ended up having to replace this transistor. That also came from that GTX 970. That's why I have a box of dead GPUs, because you never know when you might need a transistor that like EVGA like to use, because EVGA card. But anyway, yeah, I'm not sure if it's like a production date thing, because the 6823 and the 6820 Fairchild Semiconductor power stages, they have the same pinout, they have the same current rating. There's a bunch of GTX 980 Ti's out there that use the 6820s, and I guess maybe later production uses 23s. But like, this phase works fully. I've checked it with the oscilloscope, and yeah, so that's, I guess, if you're wondering about that, is like, can you use 6823s or 6820? Like, can you mix these power stages? I'd say yes. I can't see any reason why that would cause any issues. Actually, maybe 6823s are older. The numbering schemes for power stages don't necessarily make a lot of sense sometimes. As in, like, you'd think like the bigger number is like better always or something, and some manufacturers do it the like backwards for that. But anyway, yeah, like a really wacky, no, because you have 3550, which is the best one, then 3551, 3553. Whatever. Anyway, yeah, so this is a 6820 instead of a 6823, and the reason it's a 6820 is I already have a bunch of 6820s that I bought for repairing other 980 Ti's. So yeah, like other reference 980 Ti's, because a lot of your custom 980 Ti's will actually use, like, say, Asus like to use international rectifier power stages, which are completely different pinout, absolutely not interchangeable with like the Fairchild Semiconductor parts. Yeah, the reference cards, I think they all use, like, they should all use the same pinout, and so you should be able to slap, like, 6823s on there, 6820s. I guess there might be other parts that would also be compatible, but these are the only two I've encountered so far. So, yeah. But the thing is, like, I have such a good core attached to such a garbage VRM. Because this, like, it already blew up once. Why do you think that is? Um, so yeah, this is the one thing I'm kind of wondering about at this point is, like, do I want to, like, e-power this thing? Like, just replace the entire V-Core VRM instead of... I'm probably going to end up putting fuses on this board at this point, because now that I know that this core is so good, the last thing I want... Because I might accidentally blow up the VRM again. I'll try not to. Like, the thing with the, like, power delivery failures is you don't really get any warning, right? It's not like you might think, like, oh, if the VRM is making a lot of coil whine or something, it's about to, like, no, that's not how it works. Basically, when VRMs go up, they're fine, and then they're not fine. And that's it. That's, like, all that, like, you get zero warning. You just go from VRM is happily doing VRM things, and then power stage is no longer power, and then suddenly one of your power stages is a short circuit. And there's, like, no warning to it. So, you know, like, the thing is, like, like, maybe this was the first power stage to go, and the rest of them are actually perfectly, like, this is the only power stage that was having issues on this card, or maybe the other ones are ready to go at any moment now. So, and I don't really want to, you know, torture the core with random VRM failures. So yeah, I think I'm going to be putting fuses on all of the inductors just to make sure that the core lasts a bit longer. Or, well, no, so that the next time a power stage fails, it doesn't have, like, it, like, the fuse will basically minimize the amount of damage that the dead power stage can cause. Also, it'll make the troubleshooting a bit easier. And if the VRM fails again, I'm probably just going to e-power this thing, because I don't really think it makes sense to just constantly replace the power, like, you know, power stages are not consumable parts. So I don't plan to make, like, that doesn't make sense to me. So the only issue, actually, I have a dead 980 Ti Strix PCB that I could probably use as a replacement VRM for this. It'll be a massive pain to wire it up, but, like, that's like a proper 12-phase V-Core. Is it a 12-phase? Yeah, I think it's like a 12-phase V-Core VRM using international rectifier parts. So basically, like, twice the power delivery capacity of what we have here. So yeah, if this blows up again, I'm probably going to put that 980, like, I'm going to, yeah, probably put the Strix VRM on here. I haven't turned that into an e-power yet, so hopefully that's not too annoying to do. Anyway, hopefully you found this video interesting, if not particularly useful. And yeah, that's it. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. And there's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, that's it for the video. So thank you for watching, and goodbye.